and I will give a presentation about writing history by keeping a diary. If you didn't read the abstract, it's about Git and version control. But let's dive right into it. So, according to Wikipedia, a diary is a record with discrete entries arranged by date, reporting on what has happened over the course of a day or another period. It continues, diaries undertaken for institutional purposes play a role in many aspects of human civilization, including government records, business ledgers, and military records. So, diaries are used throughout our lives, but for most of us here, it will Is it gone? No. For most of us here, it will be used by writing code or by creating projects and communicating what we want to do with that code. So the primary goal of a software developer should be to communicate their intent to future developers. Keep in mind that the future developer here is in 90% yourself within a month. So you have to communicate what you were doing at the time you were writing that code. So a big concept here is context. We want it to be easy for the future developer to create the same context in their head as you are having right now. So I don't know if anybody knows this cartoon. It's you start with reading 2 lines that somebody wrote, and you start compiling them in your head. So you start to figure out what happened or what should happen. So you are running those lines of code in your head, and you are making a complex graph, and it continues. And when you finally know what's going on, your colleague comes in and says, "Did you receive that email?" And then that whole context disappears, and you're left with the 2 lines, and you have to reinitiate the whole context building. So instead of trying to create some context about what the programmer was thinking at the moment he wrote those lines, we have to add some extra documentation, so it's easier for future developers to see what's going on. This can be done in code documentation or in API documentation or in just whatever written documentation you have. But in most cases, for the developer itself, you have already a very good documentation system, and it's called version control system. In our case, this will be Git, because Git has some extra advantages over other version control systems. So who's using version control? Should it ask it the other way around? So everybody is keeping a diary already. So as I see many of you are using version control, I will try to teach you how to use it better, so it becomes an actual diary. So reestablishing the context of a piece of code is wasteful. We can't avoid it completely. So our efforts should go to reducing it as much as possible. And commit messages can do just exactly that. And as a result, a commit message shows whether a developer is a good collaborator. So you can see if you work on a big project, if you inspect the commit messages, you can see who is working on that project with a mindset of sharing the knowledge just by looking at the commits. So who knows this Richardson maturity model? I think most of you will or not, but it's just the different levels of REST. This has nothing to do with the presentation, but the presentation is built this way, so I just put my commit maturity model. Every level will talk about commits, then some guidelines of messages, and then some CLI tools. So if I go back to this, it always gets better or more strict until you hit the holy grail of commit messages. So let's get started. Level 0 is just some Git basics. So everybody knows when the presentation, at the end of the presentation, we need some context, concepts that I will explain here. So the very basic version control system is file 1, file 2, file final 1, and so on your own computer. Or it could be, if you use an IDE, that you have local history automatically enabled in that IDE. So this is the very basic version control system. Don't use it. Use something like this. We have the next is a central version control server system, and this is Subversion or CVS. So you have a central database, and every computer checks out the files of a specific version of that remote database. So if you want to commit, you have to push to that server, and then you have a new version on the server. But everybody uses Git now, and Git is a distributed version control system. So this means that every computer has its own version database. You can have a server like GitHub or GitLab or your own Git server at your company, but everybody essentially has its own version database. The way Subversion, so the centralized data version control systems work, are we have 3 files at version 1, and if we update these 2 files, we will just commit the change set to the server, and the server will store just the delta of that file. So if another person wants to check out version 4, the server will just apply all those patches to the file, and then it will present you with that version of the file. The way Git works is it uses references. So you have 3 files, and we change 2 files, and then we replace the file that we have updated. We replace it in the version database, and we use a reference for this file back to the previous version. And so it continues that we always point back to the previous unchanged version. So as we are using the repository locally, we have 3 different areas. So the Git directory, the .git directory, is where all the version history is stored. And the moment you do a checkout, you extract a specific version into the working directory. If you change 4 files, then it will show you that those files are not in sync anymore with the directory, and then you can commit those. And you have to do that in 2 steps. You have to add it to the staging area first, and then you commit everything what's in the staging area. But most of the time you can skip that because you just want to commit everything at once, and then you just go with one command directly to the Git repository. But we need this area if we want to do, if we have 4 changed files and we want to update only 2, then we have to add 2 files to that staging area and then commit it. So this is going to be important in the rest of the talk. And then this is how the how we point back to the previous version. So we have our different versions, and those are only a snapshot of that version, and the branches are just a pointer to a specific reference. So if you look at the .git directory and you look how a branch is created, it is just one file containing the commit ID where it is pointing to. And then we have the orange, and this is the working copy. So this is the one currently checked out in your working copy. So if we start to add changes to the testing, you can see it's the parent of this commit is that commit, And if we then start to update master, it goes in the other way. So you get, well, you see where we're going. So everything is pointing back always to one or more parent commits. So in the REST level 0, you had the box, which stands for plain old XML. And here we have the pork, the plain old random commit messages. So as a project drags on, my Git commit messages get less and less informative. So this is something we want to avoid, and I hope after this presentation you will feel the same. Okay, so everybody has the fundamentals of Git. So let's dive into level 1. If we want to construct good commits, we have to make sure they are atomic. And atomic commits mean that they have to be small and they have to address one problem or one case at a time. Next to being small and it has to only fix one problem at a time, it should also be the case that it has to be atomic. So if you do a change and you needed 2 commits to complete that change, then it's not atomic, because if somebody checks out the first commit, it will break the code. So this is the definition of an atomic commit. So if you write your commit message and you say change something to the login page and updated the profile, the moment you use the and word in your commit message, you know you have to split things up. So let's have a look at commit messages. When you construct a commit message, you have to explain what and why you did something instead of how you did something. If somebody wants to know how you did something, they just look at the diff and they know how you did it. You have to explain why a commit was necessary. And this is why I want only to use Git. Not only to use Git, but Git allows you to use the subject and the body. So it's like composing an email, and it's exactly how Git got started, because it uses the subject and the body, and mail headers and the body and stuff I will show you later. But you can always use one line and then a blank line, and then you can add a body as long as you want. So try to always use the body, but only if it's required. If you just fix a typo, just say you fixed the typo in the subject, there's no need to put a link to the dictionary online somewhere. So use it when you have to use it. Make sure they mean something, your commit messages, because this is the most frequent commit messages from GitHub. They used 151 million commits, and they ignored all the merge commits. And the top 2 are the initial commit is GitHub itself, which prepares the repository, so you can ignore that. The update README file is if you hit the edit button in the interface, it says update README, and nobody changes that, so they just hit submit. But the rest are not justifiable. So this is not update, first commit, dummy, fix, cleanup, test, stuff like that. It's not clear, so don't use it. Okay, so if you start using good commit messages, the git log command tools will be much more fun to work with. So if you use git log, you can see who did it, at what time they did it, and you can read the commit message. Nothing new, but you can search in those subjects and bodies. So if you want to see how many bug fixes there were on the project, you can use -grep, and then you see here bug fix in the commit message itself. Something more powerful is capital S, which can be used to search for strings that are added or deleted in the diff. So if you look for test, this is the Bitcoin repository, by the way. If you look for test, you see that there was a line added which has test multiple times in it. So this is extremely useful if you check out the project and you hit a method undefined exception, and your code still uses that method. You can just use minus uppercase s and the name of that method, and you know exactly who deleted it. And you can have a little chat with them. So this is very useful. So that was level 1. Who complies with level 1 completely? Excellent. Right. Let's go to level 2. We had atomic commits, and now we will try to create pure atomic commits. If you have a file and you change something, and you also happen to change all the tabs with 4 spaces, please commit those in 2 different commits. If somebody is reviewing your code and he sees a diff of 1,000 lines and 1 is a critical bug fix, he will not see that because all those lines are changed. So always use it in a separate commit. Not only for the people who are reviewing your code, but also for yourself. I had a project that the customer wanted a feature, and it gradually was introduced in the code base. But after a year, they wanted it to be completely extracted. So if everybody was perfectly in atomic commits, we could just say this commit, this commit, this commit, and revert it. But sometimes you have a few lines that also are committed in the same, added in the same commit, and then you can't use revert, which is a lot of work, and so you have to make sure everything is separately committed. But you can create dirty workspaces if you use, for instance, an IDE, and you save one file, and your IDE is configured to add a new line to the end of the file. And you hit save, and then you have your change, and then you have that little white space thing at the end of the file. And for that, you can use git add patch or git add interactive. And then you can add only parts of a given file to the staging area. So everybody knows that you can select 2 files, add it, and then commit those 2 files. But you can also only add specific hunks of a file to the staging area. And I created a demo. So we have the Laravel repository, and we are going to change the README file. So they have a lot of content in it here, and they have a list of sponsors, and I added my name to the list of sponsors. I'm also adding a new line at the end of the file, just to simulate the IDE logic if you would have it configured. So now we have one file that is updated. We update another file, we add some useless comments to it. And then we save that file too. And now we see we have 2 modified files in our working copy. If we look at the diff of that working copy, you see that we have 2 legitimate changes, but this is the white space added at the end of the file. And I don't want to commit it all at once, so I use -p, and then we have the first chunk, and then we can select what we want to do. Nobody knows what that means. So we use a question mark, and then you can see you have a lot of options. You can split that chunk into more chunks, so it's you can be more granularly about what you want to commit. So I don't want to commit that first one, but I will commit the white space because I want to commit that white space change in a separate commit. And here we are in a new file, and this is the comment I added to the new file. Let's say I changed a lot of things in that other file. I can just say ignore the rest of this file. I only want to add the white space change. So here we see that we have in the staging area the README, but we also have in the working copy the README. So this means one file can be split up and can be committed differently. So the git diff cached shows me the changes of what's in the staging area. And now I just committed with a perfectly constructed git message. And now you can see we have the changes that I want to commit separately still in the working copy. And I have one commit which just uses the which just adds the formatting. Okay, next up. Rewrite history if it's necessary. You are writing history by committing, but it's also possible in Git to rewrite history. Git is distributed, so everybody has its own copy. It is private, which means as long as you don't publish it to a server, you can just rewrite anything you want, which isn't published yet. And it's very flexible. You can rewrite stuff with Git. The most simple one is git commit amend, which allows you to update the previous commit. So if you add a typo to the commit message, you can just do a git commit amend, and then you can change that last commit. If the error was a few commits earlier, you can use git rebase interactive, which is fairly complicated, but it allows you to rewrite your history as you go. So I have another demo for that. I will start with an empty repository. So there's nothing in the folder and no commits at all. So let's just touch the README file. So we have a new file in the repository. We will add that file to the staging area and just commit it as initial commit, because we know that's the way to go. So we have one commit. You see here always that you have the commit message and the commit ID. This is important because if you rewrite history, those commit IDs will change. So let's change the README file and add a line. And I added a typo in the file. So, and to make things worse, I will commit it with a typo in the commit message. So here I will add it to the staging area again and write it with the error in the commit message. So it has an error in the file, which I've added in the file itself, and here we have another typo in the commit message. So I've added it, and I saw on the screen that this was wrong. So I just used git commit minus amend, and I just update the commit message, and I commit it again. And I save this, and we get a new commit. So now this is fixed, and we have added a new commit because we basically deleted the other one. You can see that's here and here. So let's add some more lines to the file. So this is another line. Okay, let's add that commit. Keep in mind that the error in the file of the previous commit is still there. So we are adding adding more content to the file and committing it to the repository. And then we saw that we had a typo in the second commit. So there's a typo here, but we added already a new commit, so we can't use minus amend. So we have to create a typo commit, which is very annoying because it pollutes your history, and you want to have a very nice looking history. So we are committing it with AM, which means add it, skip the staging area, and commit it to the repository. So now you can see that this typo actually has to be applied on this one. And it will be much nicer if you could just do that. Everything is private, so it's not published to the server yet. So we can write the history, we can rewrite the history all we want. So let's start git rebase minus interactive. And we say we want to rewrite the previous 3 commits. So here you can see the commit messages. Now we can write our kind of playbook of the rebasing playbook that will be applied to all the commits. So what we want to do is we want to delete that last typo commit, and we want to edit the first commit where we just add the typo itself. So then we will have a corrected commit, and the typo commit will just be deleted. So it starts and it says you are now on commit BE2, and you wanted it to edit that commit. So here we update the commit message, and we have to add it again to the staging area and commit it again to the repository. So here everything is good, and we have the updated file. This is modified, and it will be committed to the repository. And we have a new commit that was created in the repository. So we have to continue rebasing. So we say continue. So now we have some problems because Git is not good at applying patches which are very close to each other. So I had the first line, and then I had the second, the other lines. And Git needs some context around the patch to know where it should be applied. So I just have to clean up this a bit, and then I can commit the correct version of this. Then I have to add it to the repository, so we create again a new commit. And then we will again continue to rebase, and we set to drop the last commit. So we will end up with only 2 commits and a very nice looking Git log. So everything is rewritten. We have different commits, and now we can push it without anybody noticing we made the commit. We made the error commit. So this is how you rewrite history. So now we know how to tidy up our commits. Let's have a look at even better commit messages. Length is very important. We don't want our commit messages to run off the screen because we can't read them anymore. So use like 50 characters for the subject and 72 for the body, which you then wrap. It nicely fits on the screen. And which means you should stop using -m if you are committing from the command line, because you can't use the body, and the command line won't notify you if you are exceeding that limit. Also, in the body, use as much information as you can. Include references to tickets. If you use the pattern, you include references to those patterns, and do that with full URLs so everybody can click on them if they want. So the length is very important. If you use git log and you want to see very quickly what a commit does. In the rebase, which we did earlier, you saw only the subject, so you have to describe in the 50 characters what you were doing. And some more stuff. Even GitHub shows you this pro tip if you are exceeding the 50 characters. So if it's not, if it can't fit in here, it means you have to rethink your writing and add some more information in the description. Next up, graphs. Not this graph, but the much more prettier git log graphs, which shows you if you merged branches. Which shows you nicely how your code evolved. It's important to keep these graphs in mind, that they are looking good. So if you see here, you have the most right one is the master, and you can see that the feature branches are getting merged into master. And here you can see that they are using merges to merge master and their feature branch, and this is very annoying because you have a lot of lines crossing each other and it's not clear where the code just came from. So this shows you something what is called merge bubbles. Merge bubbles are if you have some code locally and you want to pull in the changes from GitHub. If you do a git pull, it will just create a small merge bubble and then a merge commit, which isn't even necessary because you could just have a nice looking graph which goes in one line. If you look at, if you search for merge branch master of GitHub, you see that there are 5 million commits that shouldn't even be there because you just have to configure that you want to use rebasing instead of merging when pulling from a remote server. The difference between merging and rebasing. We have a master here which has 2 new commits, and in our feature branch we really want those commits. So you could use a merge commit, what we saw in the graph which crosses lines a lot, and then you create a completely new commit which isn't necessary and which will look very strange if you merge your feature back into master. So it's much nicer to use git rebase. So what rebase does is if you are on your feature branch and you want to rebase with master, it will keep the 3 commits in memory. It will rewrite your, it will delete your feature branch and create a new one from the new master, and then it will apply all those changes on the new code. This looks very nice here, but it's often challenging because you have diffs in your feature branch which could also touch stuff in your master, and then you have those really annoying rebase errors that everybody hates. But if you do it right, like I showed you in the video, you have a much nicer history. There's also something called squashing, and squashing creates a completely new commit by combining the other commits. So here we have a feature branch, and we have commits D and E, and we want to merge them into master, and you could do that by squashing. It will kind of delete those commits and create one patch and one commit. But I don't like this because I am teaching you how to use very atomic small commits, and then if you use squashing, you just are throwing it all away and creating only one commit. The merge branch that I showed you earlier is useful in this case. If you want to merge the changes from master, from feature into master, then you can have a merge request, merge commit, and in this case, this is very useful. Okay, so let's go to level 3. At level 3, we will write suburb commit messages, and to write suburb commit messages, we have to answer some basic questions. So, why was this change necessary? How does it address the issue, and what side effects does the code have? Does this change have? So if you write your commit message, you should think about, do I answer those basic questions? This is a commit of Linus Torvalds. He is the creator of Git, and he is writing how to write a very good commit messages by committing it with a very good commit message. So you can see here that it has a subject line, it starts with an uppercase, it doesn't have a period at the end. And then you have then you have the body, and it can be multiple paragraphs, it can be lists, it can be, I often use complete stack traces of my errors that I can just commit in there. And it ends with some metadata. So you can add all different kinds of stuff to it. So this is again the Bitcoin repository. The subject is just that they changed the default confirm target from 2 to 6. If you just had that, you could also look at the code and see that they changed the commit, changed the config value. But he goes on and he says that they discussed that in IRC meetings, that there's a ticket referencing somewhere. There's a lot of information, so if something happens with the code because that value changed, you know exactly why this code was changed. So your commit messages have to be an imperative. Fix bug that did this nasty thing instead of this fixes bugs or fixed bug X, Y, Z. It's the same way git merge and git revert are using. So merge this branch into master. And a nice little trick is, if applied, this commit will fix bug X, Y, Z. So you can, if you can use those that sentence in front of your commit message, then you have good commit message. Some power tools for your commits. You can use Git hooks, which are easy to automate stuff. You can close issues by writing the sentence in the commit message. You can, if you do like bug fix slash and then the ticket number, if you do git commits and the editor will pop up, you have a hook which allows you to, for example, extract the ticket ID and add it in the editor, so you don't have to type it every time. So git hooks are very useful. You can validate the commit format and so on. I will skip this one. So every line of code is always documented. If you use git blame, on the file you can see who changed it on what date. So if something is broken, you can just do git blame of the file and you see exactly who did it. On the other hand, if you see some amazing code, just add this alias to your configuration and then you can do git praise and then you see who wrote this magnificent piece of code. So to summarize, use a format. If you start using a format, document it company-wide, project-wide. Just make sure everybody is on board and is using the same format in the specific project. So do it for the style, the content, and the metadata in the commit. Ditch GUIs. They are useful, but they only represent like 1% of everything you can do with git log or whatever other commands. Before you commit, read your code to do git diff, see what all changed, and if you do that and you see that there was additional changes added, just split them up so you have atomic commits. Don't do, and I repeat, don't do code dumps end of day, so you're hacking a whole day and then at the end of the day, oh, backup time, git commit everything to the server. This is useless and very annoying. And check your impact on the commit graph. Look, if you commit, if it's merge, rebase, or squash things, just look how that affects the graph and you will have a much better repository. And if it's necessary, rewrite history. And that concludes my talk. I think questions can be asked after I will be here for some time. So please come and talk to me, and thank you very much for listening.